Okay, now let's get on to our notes. So gravity is a force of attraction between objects that is due to their masses. Okay, we just talked about that in the little video. Anything that has matter has mass. Again, for example, I have matter, so I have mass. Now, do I matter? That's a different question. Okay, the pencil had matter, so it has mass. Okay, we went over that. Anything that has mass has gravity. Again, we went over that in the video too. If I have mass, that means I have gravity. The pencil had mass, the pencil has gravity. Okay? Obviously, the Earth has a bigger mass, so it's going to have more gravity. That's what is shown in this slide. This is the law of universal gravitation. The amount of gravity depends on the masses of the objects and the distance between them. So you can see part 1, gravitational force increases as mass increases. Okay, that just, makes sense. The bigger the mass, the bigger the gravity. Okay, the Earth has a bigger mass than I do, so it has bigger gravity. Easy. Part 2 also makes sense. Gravitational force decreases as distance increases. So the farther apart the objects are, the less gravity. The closer they are together, the more gravity. Okay, it should just make sense. And this gravity really weakens with distance very quickly. If you look at this graph over here, you can see that gravity drops off precipitously with distance. And if you think real life examples, this should make sense too. Think about going to space. Okay, you get in a rocket and you blast off into space. How far up do you have to go to get into space? Well, only about 62 miles. Okay, 62 miles up, you are in space. If you go 62 miles across the land, you're not even out of Texas. Okay, gravitational force decreases dramatically with distance. Okay, that's why I said, if you take that pencil and me and we go way, 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 way out in space, away from the Earth, away from everything else, and put that pencil right next to me, maybe our gravity or my gravity will be able to pull that pencil into me. Okay, but gravity gets really weak by distance. If I have that pencil any distance from me, even a couple inches, there's no way it would come together. Also, gravity is a very weak force, one of the weakest forces. And again, you can kind of think of everyday examples for this. If I have like a paper clip and a magnet, okay, just a tiny magnet will lift up a paper clip. Okay, that magnetic force, that little magnetic force from the magnet, is stronger than the whole mass of the Earth pulling down with gravity. Okay, so gravity is a weak force that gets weaker with distance. I can give you another quick example. It's about the 49ers. Now, not really about the football team, but the football team is named after what the story is about. Okay, the football team, the 49ers, is named after the 1849 gold rush. So in 1849, gold was discovered in California. A bunch of people rushed out to California to strike it rich. They went up to the top of the mountain and they were mining gold and getting lots of gold. They were walking down the mountain to sell their gold. Okay, so here's the mountain, and they were mining up here, and the banks were down in the valleys. So they mine up here. Here's a little pickaxe. So they're mining up here. They travel down the mountain and sell their gold at the bank. Okay, and that worked out well. Then the bankers got smart, and they said, well, they tried to trick the miners. Well, we'll climb up the mountain to you, and we'll buy the gold from you at the top of the mountain. That way you don't have to, come down the mountain. You don't have to risk getting robbed or make that effort. We'll come to you. We'll make it easy on you. Okay. Why would the bankers want to do that? Obviously, there was some benefit for them. And the benefit was the higher you go up a mountain, the farther you are from the center of the Earth. So the gold actually weighs measurably less as you go up the mountain. So they would go up the mountain, buy the gold where it weighed less, then they'd walk down the mountain, and as they walked down the mountain, they would make money because the gold started weighing more and more. It became such an issue that the government actually had to get involved, and gold is no longer weighed anymore. Gold is determined by mass, which doesn't change. And we're going to get the weight mass difference here in a couple seconds. But they actually had to change how we measure gold because of this idea. The higher you go, the farther you are from the center of the Earth, so the weaker gravity is, the less stuff weighs. It decreases so dramatically. Okay, so weight. We're just talking about it. Weight is a measure of the gravitational force on an object. It is not the same as mass. We just saw that in my last example about the gold. Okay? Mass is the amount of matter an object contains. Gravity is the force acting on that mass. So they're definitely similar. Mass is the amount of matter in the object. Gravity is the force, force acting on that mass. So they're related. An object with a greater mass will have greater weight, all other things being equal. On Earth, a 100-gram object weighs approximately 1 newton, actually around 0.98. We're going to see that a lot in labs, this 9.8 idea or 0.98 idea. Okay. So if you go to Europe and you ask somebody how much they weigh, okay, not a polite thing to ask, but if you ask them, they'll probably tell you in kilograms. Okay, kilogram, if you remember, was a unit of mass. Really, if you're asking their weight, okay, they should have told you, in newtons. Newtons is a measure of force, of weight. We talked about that, a couple lessons ago. So on Earth, it really doesn't matter, only when you start traveling to places. Okay, so if you go up to the top of Mount Everest, yeah, you weigh less, but your mass will be the same. Or if you go to the moon, which is our next example to show you the difference with these. Okay, so this picture shows the astronaut. So on Earth, the astronaut weighs 1,588 newtons. Okay. His mass on Earth is 162 kilograms. When he goes to the moon, okay, down here, his weight is less, about a sixth. Okay? He weighs less because the moon has less gravity, so it's not pulling him down as hard. Why does the moon have less gravity? Because the moon has a smaller mass. The smaller mass of the moon means how we measure his mass on the moon. You see the mass, 162, 162, the mass remained the same. Because mass is a measure of the amount of matter in an object. When he went to the moon, he didn't lose any matter. Okay? He didn't lose an arm or a leg or eat a cheeseburger or something like that. His matter is the same, so his mass is the same. Okay? Like I said, so if you're on Earth, interchanging mass and weight is not that big of a deal. People can understand. But it's when you start thinking of other things going different places, then it really matters. Okay? On Earth, it's about the same because the mass of the Earth, is staying constant. But the moon has a lot lower mass, so less gravity, less weight. Okay, the same mass here. I have one last thing with this slide that I want to mention. And still, it's getting this idea of how the mass can stay the same. Okay, so let's say I have my scale, and here's my scale. Okay, measures weight. And I put him on there, and he weighs that much. Okay, I take my scale with me to the moon, I put my scale on the moon, and then I stand on it. Okay, I understand that the astronaut isn't going to be pushing down as much because there's less gravity. Okay, so it wouldn't push the scale down as much, so it would read a smaller number, 271 in this case. Okay, I understand that. But wouldn't that also be true on the balance here? That the astronaut weighs less, he's pushing down less. So shouldn't this pan be pushed down less, which means the 162 kilograms would push down more and it would be unbalanced? That's the problem that a lot of people have with this idea. So what's the answer? Would this balance still be balanced? Okay, so if I take this balance set up to the moon and the astronaut stands on it, is it actually still going to balance out like it's showing here? Yes. Okay, if the astronaut is pushing down less here because of gravity, gravity is also pulling down less on this side, and it will balance out. Okay, so yes, I take this 162 kilogram mass and I put it on with the astronaut, and it will actually balance out. Okay, less gravity on this side is balanced by less gravity on this side. Okay, so last thing in this topic is just going over the law of universal gravitation. This relationship is so good that we can actually make a formula for the law of universal gravitation. This idea of mass and distance. Okay, the bigger the mass, the more gravity. The farther the distance, less gravity. We can put this into a formula. And you can see here Isaac Newton saying this formula. And using this formula, you can calculate the gravitational force between any two objects. Okay, so the gravitational force is the F sub g, the one you're looking for. F sub g equals capital G, that's the universal gravitational constant. And look at that number. That's an impressive number. 6.67 times 10 to the negative 11th meters cubed per kilogram second squared. Whew. Then M1 and M2 are just the masses of the objects you're trying to find the gravitational force between. Then R squared is the distance between the centers of the objects. Okay, that's the distance part. Now, we could do an example. I'm not going to spend the time doing an example, but if you want to try an example, here is an example you can do. Okay, so these numbers are for the gravitational force between the Earth and you. So the gravitational constant is constant, obviously, this number. The Earth's mass is about 5.98 times 10 to the 24th kilograms. Your mass is about 68 kilograms. And the distance between you and the center of the Earth is about 6.37 times 10 to the 6 meters. So, if you want to use these numbers and stick them into the formula and get the answer, do it. Alright, it's awesome. If you think, though, you should already know what the answer is that it's going to spit out. Okay? It's finding the gravitational force between the Earth and you. Okay, so you should already know at least about what the answer should be. Okay? And that's it for gravity. Again, the key idea is gravity is determined by mass. The more gravity. Also determined by distance. The closer the distance, the more gravity.